Present about limit comparison test. So this is from Math 161 Calculus 3 from module number 6. So I am the presenter, Alvin Kagampang. Our presentation are the topic with lesson objectives. So at the end of this discussion, the learners should be able to use limit comparison test to determine whether a series converge or diverge. Have our activity first. Identify the following series and determine if it converges or diverges. Number 1, number 2, and number 3. So you are going to pause this video if you want to answer, because the next slide is the answer. So for now, for the answer of this activity, number 1, this is an example of P series, where P or our n here is greater than 1, so it is convergent. Number 2, this one is an example of harmonic series, and it is divergent. And number 3 is a geometric series, and it is divergent. Comparison test. Limit comparison test is we can only use this test if we don't know what to compare with, or this is also used when the inequality of the comparison test work the wrong way. So if the comparison test is the condition of comparison test is not satisfied, then we will use limit comparison test. So these are the things that we need to consider in using limit comparison test. So if the two series of summation of n is equal to 1 to infinity en and summation of n is equal to 1 to infinity bn with positive terms, if their limit is not equal to 0 or a positive number, then it's either both series converge or diverge. Then if their limit is equal to 0, then obviously their series are convergence or converge. And then if their limit is infinity, then the summation of series n is equal to 1 to infinity is diverge. Both E sub n and B sub n is diverge. So that is our limit comparison test. So for this example, we will compare comparison test versus limit comparison test. So in comparison test, and for this example, they are both harmonic series and they are both divergent. So for this test, in comparison test, as you can see here, if their Bn is greater than En, then we can use comparison test. But in limit comparison test, if En is bigger than B sub n, even if it is harmonic series, then we will use limit comparison test. So to fully understand this topic, I will show you some examples for convergent and divergent examples. So now this is the example of limit comparison test. So let's see if this one is convergent or divergent. So as you can see here in the series, this one is the summation of n is equal to 1 to infinity and multiplied by square root of n raised to 4 plus 1 and divided by n raised to 6 plus 2n minus 3. So you can see here, this one is plus 1, so it makes our numerator larger, and this one minus 3, so it makes our denominator smaller. So what is our degree here? Our degree here is 4, but because this one is the square root, then our degree now is equal approximately is equal to 2. So but here we don't have square root, so our degree is 6, is equal to 6. So this is now our degree, so it means this one is our Bn, or B sub n is equal to n squared divided by n raised to 6. So what is n squared divided by n raised to 6? It can simplify into 1 over 2 minus 6 is 4, so n raised to 4. So this one is an example of P series. So, as you can observe, what kind of P series is this? Convergent or divergent? Because our n is greater than 1, then it is convergent. Or it converge. So it converge. So let's test if their limit of this one using limit comparison test is also converge. So our limit now is n approaches to infinity. This one is our en. So e sub n divided by b sub n. So what are e sub n? This one. So this will become limit of n approaches to infinity. Square root of n raised to 4 plus 1 divided by n raised to 6 plus 2n minus 3. And our bn is this one. Divided by bn, which is 1 over n raised to 4. So, to get the limit of this one, we need to multiply this en and bn with the reciprocal of this one. So, this will equivalent to limit of n to infinity, square root of n raised to 4 plus 1 divided by, just copy this en, n raised to 6 plus 2n minus 3 multiplied by the reciprocal of this one, which is n raised to 4 over 1. So, to compute this one, we will get limit of, copy this one first, n raised to 4 plus 1. So, add this one, n raised to 4 plus 4, the degree is 8, so n raised to 8. Divided by, just copy this one because we only have one value here. When we multiply this one, it answers also this one. So, n raised to 6 plus 2n minus 3. So, to simplify this one, we will add this degree here. This will become limit of square root of n raised to 12 because 8 plus 4 is 12 plus multiply this one, n raised to 8 multiplied by 1 is n raised to 8 divided by, just copy this denominator, n raised to 6 plus 2n minus 3. So what is our highest degree here? 12 in numerator and 6 in denominator. So this one is equal to n approaches to infinity, square root of n raised to 12 divided by n raised to 6. This one is equal to both because this is square root, or you can divided by 2. So 12 divided 2 is 6. So n raised to 6 over, just copy this one, n raised to 6, or this one is 1. So when we look at our condition for limit comparison test, if bn is with positive numbers, just like this, or our limit of a sub n over b sub n is not equal to 0 but in positive number, then this series is also convergent or also converge because our limit is not equal to 0 and this one is a positive number. So that one, this limit also converges by using limit comparison test. So this is another example for limit comparison test. So this one is our series. So you can see here, this is 3 raised to n and then 2 raised to n. So it makes our numerator larger and makes our denominator smaller. So what is the degree here? degree in this one is 3n. And here is 2n. So this degrees is our bn, b sub n. So our b sub n is equal to 3 raised to n over 2 raised to n. So this one is an example of what series? It is geometric series. So their common ratio is 3 halves. So this one is equivalent to 3 halves squared. This is a geometric series. And then the common ratio is 3 halves. And if the ratio is greater than 1, then this is a divergent. So let's now have our limit. So limit here is a sub n over b sub n. So this is our a sub n. And this one is our b sub n. Limit of what is our a sub n? We have 2 plus 3 raised to n divided by 5 plus 2 raised to n. So we just divide it by b sub n. So we have 3 raised to n divided by 2 raised to n. Just simplify this one. We need to multiply the reciprocal of this one. So by the way, this one is approaches to infinity. So limit approaches to infinity. We just multiply the reciprocal of this one to make it to simplify this series. So 2 plus 3 raised to n divided by 5 plus 2 raised to n multiplied. What is the reciprocal of this one? We have 2 raised to n divided by 3 raised to n. So now we need to compute this part. Now I will get 2 multiplied by 2n is 2 multiplied by 2n plus multiply this one. So we have 6n. So in our denominator, 5 multiplied by 3n, 3 raised to n, plus, multiply this one, same, we have 6 raised to n. Because this one, we have the same value, we just need to divide it both to 6 raised to n. So we just divide both to raised to n to get this value. So now our limit will become limit of n approaches to infinity. So now our limit is 2 multiplied by 2 raised to n divided by 6 raised to n is equal to 1/3 raised to n plus 6 divided 6 is 1. So we have here 1 divided by 5 multiplied by 1/2 raised to n, because this is 3 and divided 6 is 1/2, plus 6 divided 6 is 1. So this, at this part, we can cancel this out because this one is equal to 0 and this one is equal to 0. So we have only 1. So as I've said, if the limit of a sub n divided by b sub n, if their limit is not equal to 0, then that series can be convergent or divergent. But here, our bn is an example of geometric series and it is divergent. So it means that this one, because it is a positive number, then this series is also, our en is also divergent. So therefore this series is also diverge. So that ends for our examples for limit comparison test. I hope that you learned something from this tutorial. Thank you.